Welcome to another thrilling installment of ANOVAs. Today we're going to talk about factorial designs. It's used with two or more independent variables. This is a key difference. Instead of groups, we're talking about actual independent variables. This allows us a much deeper look into what's going on than we have been able to otherwise. We have three different types of hypotheses. This one we have two main effect hypotheses, one interaction. We're going to talk about graphing the results, how to do calculations, SPSS, and how it works with within and mixed subjects designs. So what happens here is we end up with essentially four groups if we have a 2x2 design. So we have word type, which is one variable, strategy, which is another variable, and within those we have wrote and imagery for strategy, and the word type is either concrete or abstract. Concrete means something that you can think of like a keyboard, a computer, a phone. Whereas strategy is wrote, where you just keep saying the thing again and again and again. Imagery, where you link up an image to whatever the word is. We're going to break these down to people who use both the concrete and the wrote, abstract and wrote, imagery and concrete, imagery and abstract. And so those two independent variables are now called factors. So we're going to do no effect of word type, which is the main. So it's no effect of whatever the first factor is. The second one's going to be no effect of the second factor, which is strategy. Then the interaction is going to be no factor 1 by factor 2 interaction. In this case, it's no word type by strategy interaction. An interaction is where one independent variable can either help or hinder the outcome based upon the other one. So for instance, in this case, it is pretty evident that doing imagery with concrete words like memorizing ball should have an influence, whereas just doing imagery on its own with abstract may not have an influence, or imagery by itself. We could also do wrote versus concrete, and wrote as abstract, and see which one has the biggest help. So what this will do is allow us to look and see under what conditions we can get the best results. So again, factorial design. So we can look at it. This over here represents words memorized. So 5 words, 5 words, 5, 10 for imagery and concrete. We can see that, look, concrete versus abstract, concrete memorizes more. Wrote versus imagery, imagery has more of a memorization help. But if we look at this, there's an interaction where if we do concrete imagery, it's like, wow, that is so much better than the rest. So that's what a interaction looks like. Notice in here that the interaction can be shown by that there is an intersection, intersection, interaction, intersection, interaction. If lines are parallel in a graph, there is no interaction. All right, now this looks kind of scary. We're pulling it from our book. But what's happening here is if we just look at the top line, A just represents everything as it relates to factor A. And so this is the number of groups for factor A, which our case is 2. Sums of squares for between is the same thing as we've done before. It's still the group minus the grand mean squared times the number of people. Just as we did in between, just as we did within. Sums of squared is still, mean squared is still sums of squared over degrees of freedom. In our F, just like within subject design ANOVA, it is the mean squared of A, which is factor A, this first one, which is the between subjects, over error. Same thing for B. In this case, B just represents how many groups are for B. In this case, it's 2. Minus 1 for our degrees of freedom. Sums of squared, same way that we did it before. Instead of using the group means for word type, now we're going to use them for rehearsal type. Mean squared done the same as before. And the F, instead of using mean squared A, we use mean squared B over error. The factor interaction is A times B. And to get the degrees of freedom, we just multiply A minus 1 times B minus 1. And we just subtract each category. So this is going to be, C stands for cell. So each cell. So in that case, we had 3 5s and a 10. We're going to do those minus the grand mean times the number in each cell minus sums of squared A, sums of squared B. Then we do what the remaining sums of squares is going to be our sums of squared for the interaction over the degrees of freedom for the interaction. And the F ratio is the same thing. It's the mean squared for that particular row over mean squared error. Error, A times B, so that's going to be the number of groups. So in this case, it's going to be 2 times 2 times n. N refers to the number in that cell. N always refers to the count in that cell. So over here, these are going to be different, and over here, this will be different. It's always the cell that it's pertaining to. We calculate error the same way we did before, in within, and n minus 1 for our total. And then again, this is how much each individual score minus the grand mean squared is going to be our sums of squared. And so again, for sums of squared error, it's going to be each individual score minus the cell average that it's in. So it's the actual group A, group B, group C, or group D. So we have information. We know that it's 2, so in each of these, so that's 2 minus 1. 2 minus 1 is 1. 1 times 1 is 1. There was a total of 32 people, so we ended up with 28. And we're given all this information. We know 18 divided by 1 is 18, 98 divided by 1 is 98, 50 divided by 1 is 50, 36 divided by 28 is 1.29. Notice these add up, and then we do 18 divided by 1.29, which is 13.95, 98 divided by 1.29, 75.97, 50 divided by 1.29, 38.76. And then what we do is we take a look and we figure out what our F critical is and determine whether or not there is any significance. Just like before, we would do post hoc and 2 keys, but we don't need 2 keys, remember, if we're just doing 2 groups, so there's no need for 2 keys here. Factorial is going to be the sum of squared effect. So whichever one is significant, and in this case it was all 3, we're going to do all 3 of their sums of squared over the total. So we know word type had an 18 sums of squared over 202 total, so it's 0.09. Strategy was 98 over 202, so that's 0.48. Word type by strategy, so the interaction was 50 over 202, so we had a 0.25. This is our eta square and is interpreted the same way as we had previously done. Post hocs, as we just talked about, only need to run if you have more than 2 groups. So mean squared error is the denominator. So we do the Q. And then remember, this doesn't mean multiply anything. Absolutely not. This is just telling you how to look it up. And then we do mean squared error. And then n is the 1 for that cell. So it will change depending on whether you're doing an interaction or which factor. Because there could be different numbers of group, different group numbers, and there could be different cell sizes. SPSS is done similar to between subjects, but we use the general linear model. We have outputs on how to look at this, so please take a look at this. They are online. The ANOVA assumptions, same as every other one, essentially data on an interval or ratio scale, so the output Population represented by each cell is roughly normally distributed. Homogeneity of variance, meaning that each cell has roughly the same variability. Samples of all cells are independent, meaning that you're only in one cell. A mixed design would be something like a pretest, post-test, post-test, where somebody gets the independent variable. And so the pretest could be statistical knowledge, and then at the end of the semester, both are given a post-test, but one group got the wonderful luxury of having me as a professor. And so this is another way. So this is the pre-test, post-test group design, where we have both within and between subject factors. All right, homework will be due 1 week from the date that you will get the Kahoots. Good luck, everybody, and see you in class.